Welcome, Hornets, and thank you for joining me today. Today we're going to be talking about how do we graph a basic arctangent, arcsecant, and arcsine. So let's go ahead and start with our basics. When we are talking about an arctangent, arctangents have asymptotes that are horizontal this time instead of vertical, and the horizontal asymptotes are specific, and they go between pi over 2 and negative pi over 2. Now, the equation that we're going to be working with is y equals a arctangent, of b. Now, keep in mind, we're not going to be working with c, so I'm going to leave that out, but we do have our vertical shift d. Now, when we talk about the gap here, this gap is the length of a multiplied by pi. So when we actually get down to our graphing, we're going to be adjusting our pieces based upon those A's and B's and D. So this right here has to be pi over 2 times A plus the D value. This is minus pi over 2 times the A value, and now I'm going to subtract or add the D value. There we go. Now this center point is 0 pi, and since when I multiply by A it stays 0, it's just an aspect of the vertical shift. So these are the three things that we're going to be looking at when we do our work. Now keep in mind that this A value is simply going to cause me to go up more quickly, so that my graph is still going to be following in that shape, just like this one would go like that. Now, unless we're going to put in additional points, we're not going to see this shape of our concavity. Now, we know it's concave down, and we can see that it's increasing at a decreasing rate, but unfortunately, without plotting points, we're not going to be able to actually get an accurate graph. So keep in mind that we call this sketching, all right? Now, when we're working with the Arccosine, the Arccosine looks like this. It also will use 3 points that we're going to work with, and this is at 0 pi, this is at pi over 2, and this is at pi. Now, the formula we're using is y equals a arccosine of our b. And once again, we're not putting in our c value, so we have d. That means that this is also times a plus d. This is times a plus d. And this is times a plus d. Now, this point right here has an x-coordinate now, and we have to be careful with that x-coordinate, just like with this x-coordinate and this x-coordinate. Now, the x-coordinate here is going to be 1, and it is multiplied by 1 over the absolute value of b. This turns out to be 0 times 1 over the absolute value of b. Therefore, it's not going to change. And this is pi, negative 1. Let me change that real quickly. That's negative 1. Times 1 over b. Please remember, it is an absolute value. And this is how we're going to work with these values here when we are working with an an Arccosine. Now, Arcsine looks very similar. It goes like this. And this point right in the middle is 0 pi. This point right here, so we have 0 comma, let's try that again, because it's 0 comma 0 pi. And I would like to make sure I'm being accurate. So 0, comma, 0 pi. This right here is going to be at 1, comma, pi over 2. And this point is negative 1, comma, pi over 2. And it is now a negative. Now, just as we saw with the cosine, each of these values is being altered. And we're looking at the formula y equals a arccosine of b theta, once again, no c value, please, plus d. Now, when we graph, that means that this value right here is going to be 1 times 1 over b, 0 times 1 over b, and this value right here is going to be 0 pi times a plus d. So that point right there is going to be 1 times 1 over the absolute value of b, and this value right here is pi over 2 times a plus d. Down in these two, this point right here is negative 1 times 1 over b, and this point right here is negative pi over 2 times a plus d. And that's how each of these pieces for a arcsine or an arccosine or the arctangent are going to be worked with. So let's go ahead now and take a look at a graph. We're going to graph one of each. So let's go ahead and start off with y equals the arctan of our x minus 2. Now be aware that that minus 2 is our vertical shift, and so that's where we're going to have all of our work. So I'm going to go ahead and I'm going to start with my graph. Normally I would be going from negative pi over 2 to negative pi over 2, so we're going to go down to approximately negative 0.43, because that's going to be pi over 2 minus 2. Right here is our 0 minus 2. So this is 0 minus 2, 0. Pardon. Try that again. That's going to be 0. And then we have 0 pi minus 2. And we'll put the other asymptote right down below. This is the negative pi over 2 that is being shifted, and it is therefore negative pi over 2 minus 2. Now the curve goes right in between, following in our pattern. So we have increasing at an increasing rate to increasing at a decreasing rate. And this is my arctangent curve. Let's go ahead and try the next one. This time, let's go ahead and do an arcsine, and let's change it up a little bit. Let's do y equals the arcsine of 2x. So notice we're now talking about those middle values are going to be multiplied by 1/2. So instead of going to 1 all the way out here, we're now going to go to 1/2. And we're going to go to negative 1/2. We still have the values in the same places. It's 0 pi, pi over 2, and negative pi over 2. The only thing that's changed are these x values. So our curve still goes like so. This point is 0, 0 pi. This point is 1/2 pi over 2. And this point right down here is negative 1/2 negative pi over 2. Once again, we didn't have a vertical shift to worry about. We didn't have that extension or stretch that we had to worry about. So there is our graph. Let's take a look at another one. This time, let's take a look at a cosine. Let's do y equals the arccosine. And this time we're going to do x divided by 2. Once again, the only thing that's being changed is our endpoints. So instead of going from 1 to -1, we're going to be going to 2 and -2. We still have 0 pi, pi over 2, and then going to pi. Our curve starts at 2, comma 0 pi, goes down to the 0 pi over 2, and then is going to go up to pi, -2 pi. We're now going to plot these points to 0 pi, 0 pi over 2, and -2 pi. And there is the graph of our arccosine of x divided by 2. Let's go ahead and do another one. This time, let's start making these a little bit more complicated, shall we? Let's go ahead and take a look at y equals 3 arctangent of 2 theta plus 1. We're going to put each of our pieces together in this, one at a time. We're going to start with our graph. Here's my coordinate plane. Now my first asymptote was going to be here at pi over 2, but it's been lifted by 1, and the other one was down here at negative pi over 2. So I'm going to be having my first one down here somewhere around -1/2. And let's see. Let's make sure. So I'm looking at pi over 2, so -3 pi over 2. That's going to change a little bit. Let me redraw this graph again. Y equals 3 arctan 2 theta plus 1. So I want to check that pi over 2. That pi over 2 is going to become 3 pi over 2 plus 1 and -3 pi over 2 plus 1. And those are my two asymptotes. And I know that my y values, or my x values, are going to end up being just at the 0 pi times 3 plus 1. And we also know that the y value, or the x value, is going to be 0 times 1/2. All right, so here we go. Now, -3 pi over 2 is still going to be way down below, so we're still looking at our negative value. Call it there. Then we're looking at up 1. I'm going to call that there. That's now my center line of my arctangent. And I've got another asymptote right up above. And this one is going to be up here. All right. So our first step is going to be making sure that we identify what these asymptotes are. So this is 3 pi over 2 plus 1. This is y equals 1. And this is -3 pi over 2 plus 1. Our arctangent does the same thing that it always has to do. So we're looking at squeezing up. It's a little bit elongated because of that 3. And it goes down. And we're going to label this point. This is 0, comma 1. We now have our graph of the arctangent done. That's an arctangent, 3 arctan 2 theta plus 1. Let's do one more. This time, let's do an arcsine. So let's do y equals -3 arcsine of 4 theta minus 1. Once again, we're talking about between pi over 2 and negative pi over 2. So I'm looking at -3 pi over 2 minus 1 and positive 3 pi over 2 minus 1. Notice there is a reflection that we have to watch out for. We are looking at our center line at -1. Here we go. So let's just start off. We have our first value that we need to locate. Instead of having the graph going like this, it's reflected. So we're looking at negative pi over 2 minus 1 and 3 pi over 2 minus 1. So we're looking at about right here. And -1 is going to be right there. So this is going to be the two values that I'm working with. From the center line right here. Once again, we do not have a phase shift, so we're not moving it right or left. We do have this length, so we've got to watch out. Instead of going from -1, I'm going to -1/4. Well, that's a half, so if that was 1 and -1, that's a half and half. Oops. That graph isn't quite accurate. Let's try that again. My half points aren't in the same place is all. And I'm just trying to get it so that it looks reasonable. So half, that looks a little better. Close enough. 1/4, 1/4. There we go. So here's my 1/4 negative. Here's my positive 1/4. That means that point is going to be here. This point here. We're going to the 0, so we have to make sure that we go up like that, down like that, and now we have to label our points. So we have -1/4, and this was at 3 pi over 2 minus 1. This point right down here is positive 1/4, negative 3 pi halves minus 1, and this point right here is at 0, -1. And there is my arcsine. -3 arcsine 4 and theta minus 1. So please remember, these are all based upon the shifting of the points. So we're working with the arctan. We have these 3 points. Arccosine, these 3 points. And the arctangent, these 3 points. Applying each of the transformations one at a time to each point, then plotting them, and then drawing your curve. Alrighty, that's it for the day. Thank you very much, Hornets. I appreciate you watching. Please, if this was helpful and you liked it, please make sure you click like so I have an idea. If you have comments or suggestions, please make sure you include those as well, as I do try to improve. Be well, be safe, take care, and remember it's easy to be mean, so please be nice to each other. Bye-bye now.